All right, everyone. Good morning. Oh, what happened? Okay. Yay. Okay, here we go. Technology today. Happy Tuesday. Good to see you all. In just a second, once my internet decides it's going to cooperate with me, we'll get started. Here is your do now question today. It's just a question in the chat. We're not doing a share out loud. If you don't have your video on, make sure to take a moment to turn it on. And your do now question today is, do you know any other languages? And if so, what do you speak? Just 2 minutes today, just 2 minutes. All right, we got Spanish, Urdu, some French, Spanish, Latin, and German. Okay. Thirty more seconds to get your answers in the chat. All right, let's go ahead and get started with our agenda for today. We're going to go ahead and do good things. So today, if I can find my piece of paper. Where'd it go? That's annoying. All right, so today we're going to go ahead and do good things coming from Clervins, Denim, and Elise. So Clervins, go ahead and get started. What's your good thing?
My good thing is that there's no school still.
That you like virtual school?
Yeah.
Okay, cool. Awesome. Thanks for sharing. Denim, what's your good thing?
Madden 21 just came out.
Oh, right. That's exciting. Did you get it yet?
Yes.
Awesome. Thanks for sharing. And then Elise, what's your good thing?
I don't have to work tomorrow because tomorrow's my only day off.
Oh, yay. That's exciting. You gonna do anything with your day off?
Probably not.
Okay, just relax. Cool. My good thing was that yesterday I got to go to outdoor yoga, which I always enjoy, although it was kind of hot, but it was still fun to be outside. Any questions about homework? So I know that you had those word problems that were kind of a little bit challenging. So any questions about that?
I need to help with 1 and 3.
1 and 3. Okay, I already got another request for 1, so we'll definitely go over 1, and then we'll go over 3. I am assuming that the major issue was writing down the equations, but once you have the equations, You should be good to go to put it in the calculator. Am I correct in making that assumption?
Yeah.
All right, let's go ahead. I'm going to share my dot cam. And the first problem is Marina had $24,000 to invest. She divided the money into 3 different accounts. At the end of the year, she had made $1,300 in interest. The annual yield on each of the 3 accounts was 4%, 5.5%, and 6%. The amount of money in the 4% account was 4 times the amount of money in the 5.5% account. How much had she placed in each account? The first thing you want to do is define your variables. So I chose X, Y, and Z. And I said X stood for, I don't know why it's not focusing properly. There we go. No. All right, there we go. So I said X was the money in the 4% account. I said Y was the money in the 5.5% account. And I said that Z was the money in the 6% account. And you know that she invested $24,000 total, or $24,500 total. So that means that if you add up all of the money in each account, it should equal $24,500. That should be your first equation. The second equation is a little bit tricky. So it says that the amount of interest that she earned was $1,300. So you need to know a little bit about interest to do this problem. The way you find interest is you take the percent, change it to a decimal, and then multiply it by however much money you invested. So for example, if your account gives you 4% interest, you got to change the 4% to a decimal. So that means you have to divide 4 by 100, which is 0.04. Or in other words, you need to move the decimal over to the left by 2. So it's 0.04x plus 5.5%. If you change that to a decimal, it's 0.055 times whatever amount you invested, so times Y, plus 0.06. Questions on that? And then the last one says that the amount of money in the 4% account, so the 4% account is X, is equal to 4 times the amount in the 5.5% account, so 4 times Y. So those are your 3 equations. Any questions about that for those of you that asked about number 1? Okay, so from there you should be able to put it in your matrix. You will have to change this last equation so that the Y is over to the other side because you can't put it in the matrix as is. So other than that, you should be good to go. The third one, Billy's Restaurant ordered 200 flowers for Mother's Day. They ordered carnations at $150 each, roses at $575 each, and daisies at $260 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came out to $589.50. How many of each type of flower was ordered? So again, I did X, Y, and Z. And X stood for carnations. Y was roses, and Z was daisies. So I know that they ordered 200 flowers total. So X plus Y plus Z is equal to 200. I know that the total order was $589.50. So the money for each, let's see, it was carnations were $150 each, so $150X. Roses were $575 each, so $575Y. And then the daisies were $260 each, so 260Z is equal to 589.50.
Hmm.
Guess what the fuck I just did?
Questions?
What?
All right, and then the last one, we've got 20 fewer roses than daisies. So the daisies, the roses is Y. And then 20 fewer than the daisies. So Z minus 20 would give you the roses, which is Y. And then again, you'll need to change that last equation so that it's ready for your calculator. So you'll need to move the Z over to get that answer. Any questions about how to get the equations for number 3?
So wait, when we move the 20,
No,
would it be the X or the total?
you don't want to move the 20, you want to move the Z. So you would do subtract Z from both sides. So you'll get Y minus Z is equal to negative 20. Any other questions? Okay, let's go ahead and get started with today's notes then. So today we're going to be talking about quadratic functions. So we're starting our new unit, which is on quadratic functions. And this should seem kind of similar because we talked about transforming absolute value functions. And you'll realize that it's the same exact rules regardless of your original parent function. The only thing that changes is, again, the original parent function. So before we talked about absolute value, today we're talking about quadratic. So here's your parent function. It's always going to be f of x is equal to x squared. So the quadratic is that squared part. So f of x is equal to x squared. All right, just like we did with absolute value, we want to know what that parent function looks like. So we're going to create a table of values. And for my x's, I'm going to choose -2, -1, 0, 1, and 2. All right, so we have to plug each of these x values into our function. You can do it by hand, you can do it by calculator. If you're going to use a calculator, make sure you put parentheses around the x. So you want to do parentheses -2, close the parentheses, and the squared button is right here underneath the x to the -1. And the reason why we have to put parentheses is because anytime you square a number, it turns to a positive. So -2 squared is 4. If you don't put the parentheses, your calculator will say -4, which is not what you want. So make sure you put the parentheses. All right, from here, let's go ahead and plug in -1. So -1 squared is 1. Was anyone else having issues with accessing the notes for today?
I was.
Okay,
I was too.
weird. Okay, somehow that didn't happen for period 1. So let's go back and check. Hopefully it wasn't an error on my end, but it could be. Thanks for sending me an email, Alexis. For those of you that were having issues, what's the issue? What is it saying? Because on my
Like, it said 503 error, something.
huh?
And
Okay.
it couldn't be satisfied.
When like yeah, it has a whole bunch of stuff under it. When I clicked on it,
Really?
it says error, and then under it says some other stuff.
When you click on the notes section,
Yeah,
it doesn't even give you the option to download it.
no.
That's very odd because yeah, it's showing up on my version. So I would suggest, what browser are you all using? It might be a browser issue because it is showing up on mine and I can't figure out why it's not showing up on yours.
I'm on Chrome.
Okay. All right. Yeah, I can't figure it out right now. All I would suggest is just watch the video, copy down whatever you can. And then if you all want to send me an email, for those of you that can't access it, I will email you directly the PDF so that hopefully you can print it out later. Does that work?
Where do you keep your videos from yesterday?
It's on modules, so I think it should be uploaded again. Yeah, it's under modules. If you go down to the date 8/24, it says 8/24 lecture video. It will take you to the YouTube link. All right, so let's continue. So plug in the 0. So 0 squared is 0. And then 1 squared is 1, 2 squared is 4. You should notice that the y values will repeat, and that is a characteristic of quadratic functions. So let's go ahead and plot these. So we've got -2, 4. We've got -1, 1, 0, 0, 1, 1, and 2, 4. And that is your parent graph. So you'll notice that it's a U shape. That's called a parabola. So all quadratic functions will always have that U shape. But we're not just gonna graph the quadratic function, we're also going to transform it. So here are the rules for transforming quadratic functions. They should sound really familiar because they're the exact same as the rules for absolute value. And you'll notice that for every unit that we do in Algebra 2, we're always going to use the same rules. So especially after like chapter 3 or chapter 4, these should be ingrained in you, which is kind of nice because you don't have to memorize anything new. It's all the same. So here's the vertex or the graphing form of the quadratic. It's f of x is equal to a times x minus h squared plus k. So the h will always be in the parentheses next to the x. The a will always be in front of the parentheses, and the k will be at the end. Again, h is the horizontal shift. And if it's a plus, it shifts it to the left. And if it's a minus, it shifts it to the right. K, so K is outside of the parentheses. It's the vertical shift. And if it's a positive, it shifts it up. If it's a negative, it shifts it down. If A is positive, the parabola faces upwards like a smile. If A is negative, the parabola faces downwards like a frown. And this is what we call a reflection across the x-axis. The last thing the A value is going to tell you is whether you have a stretch or a shrink. So if your absolute value of A, so that means that if you change A to a positive and that number is still bigger than 1, it's going to be a vertical stretch. And then if your A is, so it's between 0 and 1, so if you change it to a positive and it's between 0 and 1, so usually that's if it's like a fraction, that's going to be a shrink. And then just like with absolute value, your vertex is h comma k, but remember that h is the opposite sign when you put it in the vertex. All right, does anyone still need this before I flip it over?
I do.
Are we good?
Yeah.
Cool. All right, let's go ahead and look at some examples. So for the directions, we want to describe the translation or transformation with words, graph the function and its transformation, then identify the vertex. So let's look at example 1. We've got f of x equals x minus 3 squared minus 4. So the first step, identify your a, your h, and your k, your a, h, and k. All right, I'm gonna go ahead and call on someone to help me out. What's gonna be my A, what's gonna be my H, and what's gonna be my K? What do you have for me, Anam?
The A is -4.
Remember, the A is always the number in front of the parentheses. Do I have a number in front of the parentheses?
No.
No, so I can assume that that number is 1. So your A is 1. What's your H?
-3,
Mm-hmm.
and then the K is -4.
All right, so go ahead and describe the transformation for me. Describe the transformation for me. Thank you, Anam. What's the transformation, Imani?
The transformation is
How's my graph moving? Is it moving up, down, left, right?
down.
Down by how many?
3.
So remember, up and down is your K value. So what's your K value?
Oh, 4.
So down 4. What is that H gonna do?
Left 3.
Left 3, good. Actually, no, before, not left 3. What does the minus mean?
Right 3.
Right. And because you're 1, since it's a positive, there's no reflection, and because it's just 1, there's no stretch or shrink. So the only transformation is right 3, down 4. All right, next question. What is my vertex? What's my vertex? What do you think, Nick?
Is it 1?
Remember, your vertex is always opposite of H, comma K. So what would your vertex be?
Opposite of. Is it -3, -4?
Remember, it's the opposite of H. So if it's negative, then when you put it in the vertex, it has to change to a positive. So 3 is -4. Does that make sense?
Yeah.
All right, so now we're gonna go ahead and do a table of values. So just like we did for absolute value, your vertex is gonna go right smack dab in the middle of your table of values. So 3, -4 goes in the middle. And then you wanna choose 2 numbers that are less than 3. So let's go with 2, 1, and 2 numbers that are greater than 3. So let's go with 4, 5. And then you want to plug each of those into your calculator. So you're going to plug them into this formula. So let's start with plugging in 1. So you want to do parentheses. 1 minus 3, close the parentheses, and then square it, minus 4. And that's going to give you 0. And then we're going to do parentheses 2 minus 3, square it, minus 4, and that's going to give you -3. And then you're going to do 4 minus 3, close your parentheses, square it, minus 4 is going to give you -3. And then you're going to do 5 minus 3, square it, minus 4. That's going to give you 0. And you should notice that your y value should repeat on either side of the vertex. That's what you want to happen. So let's go ahead and graph this. You've got 1, 0. 2, -3, 3, -4, 4, -3, and 5, 0. Questions on how we graphed that? The last step, you want to graph the original parent function. So that came from the front page. So you would just, I highly recommend memorizing it. It's the easiest way to do it. But the points are -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So you'll notice that to get from the green to the black graph, we went to the right 3, 1, 2, 3, down 4. That's all we did. We shifted it to the right 3, down 4. Any questions about example 1?
How did you find the green again?
That just came from the front page. Remember when we did the parent function?
Oh, yeah.
It's just that one.
I have a question.
Yeah, what's up?
So will we always use that same parent function?
Mm-hmm. Yes. Any other questions? All right, let's look at example 2. So we've got -2x squared. So first thing we're going to do is find the a, the h, and the k. So I'm going to go and call on someone for that. What's my a, what's my h, and what's my k? What do you think, Noah?
The A, -2. I really don't know about the others.
So yeah, this one's a little tricky, but you notice that there's nothing inside the parentheses. There's not even parentheses to begin with. So that means you don't have an h, which means that we represent that with a 0. So h is 0, and then Noah, could you tell me what k is? Do we have a k?
I don't think so.
No.
So, 0.
0. Yep, because we don't have a number added or subtracted after that. So that means that k is also equal to 0. All right, so how does this transform our graph? Go ahead and describe the transformation for me. What do you have, Gavin?
Is it like 0, 0, like no solution or something?
Not necessarily. So the only number we have, Gavin, is that -2 for the a, right?
Yeah.
So how is that going to shift my graph? What's that going to do to it?
Down 2.
So the
Or-
negative means that it's going to be reflected. So it's going to be flipped over the x-axis. So we're going to say reflected over the x. And then you'll notice if I change this negative to a positive, it becomes +2. Gavin, is that bigger than 1 or less than 1?
What did you say?
So you change your a value to a positive if it's not already positive. So we've got a +2. Is that number bigger than 1 or less than 1?
Bigger.
Bigger. So if that number is bigger than 1 when you change it to a positive, it's going to be a vertical stretch. And in this case, by a factor of 2. Does that make sense? So if it's a negative, it's a reflection. And then you change it to a positive to see if it's a stretch or a shrink. So we have reflected over the x-axis and a vertical stretch by 2. Gavin, next question. What's the vertex going to be? What's the vertex for this problem? What do you think, Christian?
The vertex will be 0, 0.
Yep, because it's always h comma k. So your h was 0, your k was 0. We don't have to worry about the opposite for the h because it's. So let's go ahead and write our table of values. So vertex goes smack dab in the middle. So 0, 0 goes in the middle of your table of values. You're going to choose two x values that are smaller. So let's go with -1 and -2. And then two x values that are bigger. So let's go with 1 and 2. All right, now we're going to plug it into our calculator. So you can take out your calculators. Let's start by plugging in -2. So you have the -2 from your equation. And then you're going to do parentheses and plug in a -2. Close your parentheses, press the squared button. So it's -8. So you've got -2, -8. Then we've got -1, close your parentheses, or sorry, not -1, -2 from the original equation, close your parentheses, -1 squared, and that's -2. Now we're going to plug in 1. So you've got -2 parentheses 1 squared, which is -2. And then you've got -2 parentheses 2 squared, which is -8. So you should notice that the y values repeat. That's what you want. Any questions about this? All right, let's go ahead and graph. So you've got -2, -8. This won't fit on your graph, so you can kind of guesstimate it. So 1, 2, 3, 4, 5, 6, 7, 8-ish. Then you've got -1, -2, 0, 0, 1, -2, and 2, -8. Questions on that?
So for the transformation, if it's over 1, it's a stretch.
Yes.
Or, okay, and if it's under, or if it's 0, it's a shrink.
It will never be 0 because if your a value was 0, then you wouldn't even have an x. But if it's between 0 and 1, it's a shrink.
Okay.
Any other questions? All right, so let's go ahead and graph the original parent function, which is at -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And you'll notice that I reflected it, so it's upside down. And I stretched it, so it's kind of skinnier than it was before. Questions on that?
How did you know it was reflected over the x-axis?
Because your a value is negative. Any other questions? All right, let's go to that last example. Does anyone need more time to get this one down before I flip it? Last two examples, rather. All right, example 3, we've got -1/2 x plus 4 squared plus 1. I need you to identify your a, your h, and your k, and I'm going to go in and call on someone. What's my a? What's my h? What's my k? What's my a? What's my h? What's my k? What do you think, Henry?
Your A is 1.
Remember, a is always the number in front of your parentheses.
There is the number.
It's -1/2, right? Because that's the
Oh,
number.
-1. Oh, see, yeah. Oh, I was thinking. Never mind. Yeah, you're right. And then H is.
Sorry, I think you cut out. What was h again? Did we lose you, Henry?
It broke.
Okay, can you go ahead? I didn't hear what you said for h.
Is H is it 16?
No, just what's the number inside the parentheses?
Oh, 4. And then H is 1. I mean, K is 1.
Good. Thank you, Henry. Go ahead and describe the transformation for me then. Go ahead and describe the transformation for me. What do you have, Jonathan?
Is it reflected over the x-axis?
Because it's a negative A. Good.
It's going left 4.
Positive 8 to the left 4. Good.
And up 1.
Up 1. And there's one other thing. We have to change the A value to a positive. So positive, this negative 1/2 becomes a positive 1/2. And then you have to compare that. Say, is that less than 1 or is that greater than 1? And since 1/2 is less than 1, it's going to be a shrink, a vertical shrink, excuse me, by 1/2. So there's a lot of stuff happening in this graph. This will probably be the most complicated one that you'll see.
So
All right.
if it's
Sorry, go.
so if the A is positive, is it reflected over the y-axis?
No, if A is positive, then there is no reflection. It is just
Okay.
upright. Yep.
All right.
Don't worry about it if it's a negative. What's my vertex going to be? What's my vertex going to be? What do you think, JJ? Where's JJ?
Can you say that again?
What's my vertex going to be?
Let me see. Because I took a picture of the example you gave us.
That's okay. So remember, your vertex is just H comma K, where H is the opposite sign.
Yeah. So the vertex would be negative 1.
Negative. So it's the opposite. That's your H.
Oh, well, negative 4.
Uh-huh.
And then 1.
Always H comma K, where H is the opposite. So we're going to write our table of values. Remember, your vertex goes smack dab in the middle of your table of values, and you're going to choose two numbers that are smaller than negative 4. So let's go with negative 5 and negative 6. And two numbers that are bigger than negative 4. So let's go with negative 3 and negative 2. And now we get to plug these bad boys into our calculator. We haven't dealt with a fraction yet. So to put a fraction into your calculator, if you're trying to do negative 1/2, just do parentheses, negative 1 divided by 2. And then parentheses, we're going to plug in negative 6 first. So negative 6 plus 4 squared plus 1. So that'll give us negative 1. Then we're going to do negative 5. So negative 1 divided by 2, parentheses, negative 5 plus 4 squared plus 1. That's going to give us 0.5. Now we're going to plug in negative 3. So negative 1 divided by 2, parentheses, negative 3 plus 4 squared plus 1, 0.5. You'll notice that they're repeating. That's what you want. And we've got negative 1 divided by 2, parentheses, negative 2 plus 4 squared plus 1 is negative 1. And then we're going to go ahead and graph those. So we've got negative 6, negative 1, negative 5, 0.5, negative 4, 1, negative 3, 0.5, and then negative 2, negative 1. So you'll notice that we reflected it, so it's upside down now. We shifted it to the left 4, up 1, and it's shrunk. Excuse me, I'm not an English teacher. Which means that it looks a little fatter than normal. So if I graph my original parent function, you should be able to see that transformation. Any questions on that? Anyone need more time for that one? All right, the last one, example 4, I'm going to quickly go over it. Actually, yeah, I think we have time for it. Write the equation of a parabola that has been vertically shrunk by 1/2 and translated 6 units to the right and 2 units up. So vertically shrunk, that means that's your A value. 1/2 is your A value. 6 units to the right, right is a horizontal shift, so H value is 6. And then up, that's a vertical shift, so your K value is 2. So you know your formula is f of x is equal to a times x minus h squared plus k. So all you have to do now is plug in your values. We know that the a was 1/2, so I'm going to put 1/2 in front of the parentheses. Keep the x. You're going 6 units to the right. Right means minus 6 squared. And then 2 units up. So up is plus, and then 2. Any questions about example 4? I know I went through that kind of quickly, but we can go over that again tomorrow if need be. Any questions? Does anyone
Can you
need?
explain how
Go for it.
did we get the vertex on example 1?
How did we get the vertex on example 1? So vertex is always h comma k. So do you see how the h value was -3 in example 1?
Yeah.
So you just have to take the opposite of that. So the opposite of -3 would be +3. And then -4.
Take the opposite.
Yeah, h is always opposite, k stays the same.
Okay.
Any other questions? Okay. Anyone still need this before I switch the screen? All right. So your homework tonight is the worksheet from last night on Canvas. Make sure that you upload your finished work by tonight at 11:59. And then you have a new Big Ideas Math assignment. It's 2.1 part 1. It's going to be due tomorrow at 11:59 p.m. So if you have any questions on that, I can answer those for you tomorrow during class. All right, that's all for me. If you have no questions, feel free to log off. I'll see you tomorrow. I'll stick around till the end of the period if anyone does have any questions.
So for question on number 2 on the homework,
Yes.
the equation is already set up, right?
Are you talking about the word problems or the Big Ideas Math one?
The word problems.
Yeah, the equations are already set up for you. So all you need to do is set up the matrix and then solve it.
Okay.
I have a question.
Yeah, what's up, Ida?
Do you have after hours today or no?
I don't. The office hours will be Friday morning.
Okay. I had a question over this homework.
On the word problems homework?
Yeah.
I can answer it for you today after school. That's fine. I probably can only stay for like 10 minutes, but we can do it then.
Yeah, it's just one question.
Okay, yeah, let's do that. So I'll log in at 2:40.
Okay, thanks.
Mm-hmm.